Assistant Houston, this is Commander Diaz. Do we have any debris close to our trajectory?
Evening, Commander. Negative on that. Clear sailing as far as we can see down here. If there was any cause for alarm, you'd know we'd see it too. Your crew members can keep sleeping tight.
Well, I'm seeing something out there. I can't make it out, but whatever it is, it's getting closer.
Tell you, Commander, we're not anything.
Houston, repeat again. Can't be.
Diaz, copy. Commander Diaz, do you copy?
Houston, you're not gonna believe this. I'm picking up transmissions on the ham radio that sound identical to the suit-side experiment. And that debris, it's an Orlan spacesuit.
I'm not sure I'm hearing you right. Repeat that, Commander?
Suit set. I'm seeing suit set.
You're mistaken, Diaz. Suit set re-entered the atmosphere and burned up years ago. It's impossible.
Yeah, I know it's impossible,
But I know what I'm saying. It's suit set. It's come back. And it's not just in orbit. It's headed right for the ISS. Commander, you're not making any sense. Say that again? Commander. Man, you need to try
Up here, the sky is black. Up here, the sky is black.
Up here, the sky is black.
I need to alert the crew.
Diaz. 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 Commander Diaz, do you copy? Diaz.
Hello, everyone, and welcome back to Inside Unreal, a show where we learn, explore, and celebrate everything Unreal. I am your host, Dan Hutnick, and today I am joined by two lovely folks who have agreed to join us today to talk about the optimization journey of Far, Far West. So, without further ado, let's get them introduced, starting with, you know him, you love him, Ari. How you doing, Ari?
It's me. It's Ari. Hi, everyone. I'm super happy to be here on the stream. Thanks for having me, Dan.
Absolutely. Thank you for joining us. For folks who don't know you, who are you? What do you do? What would they know you from? Maybe
Yeah. So hi, everyone. I work for the technical developer relations team at Epic Games, which basically means that I focus a lot on, we're under the customer success umbrella, so we try to make sure the customers succeed. And I used to be an evangelist, which is probably how many people know me. So I used to do a lot of presentations, do a lot of videos and stuff, and go to basically any conference that would have me. Now I'm in technical developer relations team, which doesn't have me going to every conference anymore, but I try to focus even more on proactive content, meaning being on the live stream and teaching people how to make well-performing games, because it's also kind of selfishness, because I just want the games I play to perform better. And yeah, a lot of my time goes into proactive content, meaning like teaching people how to make their games more optimized, and any way I can to make them more interesting, including wearing silly costumes.
Yes, we have to showcase the awesome costumes that you have on display in the background. And next, last but not least, of course, Tom, how are you doing?
I'm doing fine, thank you. So I'm Tom Looman. I do a lot of Unreal Engine stuff. I make a lot of tutorials. I have some online courses, and I do like consulting work for games like Far Far West to help optimize the game. And so they were kind enough to let us like dig into this game and show off some optimizations that they made, and also some things that we can still improve because the game is only in early access, and so there's still always things to improve further. So that's also something we're going to look into today.
Yeah, I'm personally really excited about the fact that this is a real live actual game that's in progress, that's giving us an extremely great real world look at this, right? Like, we have a lot of awesome templates and samples and things like that, and those are all great and, you know, have tons of valuable information, but there is a difference a little bit in an actual real world live game, right? Where that stuff changes over time. It's not only just like a, you know, project you have to optimize and then release, but then as it evolves and grows and things like that, there's continuous optimizations and things that have to come with that. So really excited to explore this one. And we do have a trailer that we will play here in just a second. But real quick, before we go any further, if you have any questions about optimization for Far Far West, please leave them in the comments. Brackets, question, followed by your question, and we will throw them to these guests at the end. Maybe a few in you know, during, if they're really applicable. We'll save most of them towards the end. Please keep these questions related to this topic here. If you have any questions outside that purview, please head over to the EDC, our Epic Developer Community, where we have our forums, tutorials, documentation, and so much more. With that, do we have anything? Do we want to do maybe like a brief description of what Far Far West is before we jump into the trailer, or do we want the trailer to do most of the talking?
I think the trailer can do a lot of the talking, or like most of the talking. It's pretty clear. Yeah.
Perfect. Let's jump in.
All right. It's a banger trailer for a banger game.
Exactly.
Of course, the least we can do is showing their trailer for offering for Evil Raptor, offering us to like dig into their game, and like how I usually call it, showing the dirty laundry. And if the audience likes what they're about to see and wants more of it, me and Matt Osterley also have done this twice before with two other games. So you can check out, well, either just go to my website, Ari.games, there's links to it there, or you can just search for Profiling with Passion and Profiling with Pirates. And that's the one, this costume over there, where we have Holly the Profiling Pirate, where we actually profile a pirate game. But now, Wild Wild West, unfortunately, I don't have a Wild Wild West costume. I actually thought I should have maybe brought a cowboy hat. But yeah, maybe let's just dive right in. Dan, can you show my screen, please? Or Yes,
I will, real quick. But I just wanted to say real quick. Apparently, there was a little bit of performance issues, hilariously enough, with the trailer. That's certainly on me. The trailer itself looks absolutely great, but I am seeing a couple people in chat saying like a live stream about optimization with a low frame rate trailer is unfortunate. That is on me, folks. I apologize. The trailer runs beautifully, and the game runs beautifully, as we are about to see.
So I need to use this to see the hitches in the trailer.
He's coming for me. Perfect. But yes, if you're ready to jump in, we can go ahead and share your screen.
Yes. So I made this awesome image of me and Tom. Thank you, Tom, for being such a good support about it. And how we were involved is that Tom helped them basically optimize the game. And I wasn't really involved, but just before the stream a few days ago, Tom sent me a development build of the game. So I was able to kind of like take a deeper look into it and make sure, like, are you guys doing everything just fine? Like, do we have the Hits Hunter approval? And one of the first things I did was to just play around the game, see how it performed. And I'm always very curious about streaming, how games are handled streaming, because like that's a really, really easy way to mess up your game is if you have a big open world and you just have it all loaded at once instead of having world partition cells. And I was playing it and I was looking in the distance. It was really hard to see in the distance whether you had 8 slots or not, hierarchical level of detail, when you basically unload a big part of the map and then replace it with one static mesh instead. So I use the console command because I have a development build, and you can do almost anything with a development build. It's so cool. And I used the command show fog, which toggles the visibility of the fog. And this is for the exponential height fog, and I think other types of fogs also. It's a really nice command. I recommend everyone check it out in your own games. And now I don't have this kind of visual barrier. I can actually see as far as I can, like as far as the map reaches. And interestingly enough, it doesn't look like there are any 8 slots. It looks like the whole map is loaded. And if you look really close, you can see that all the Niagara particles are spawning. Like you can see the smokes. And if you peer in really closely, you can see like there's like these little blue dots here and there. Those are collectibles. And here we have like these kind of, I think these are holes that you can teleport between 2 places, and it goes throughout the map. So I thought that's interesting. It looks like the entire map is loaded, and there's no world partition streaming or no 8 slots maybe. So next step was, okay, there's a few ways to confirm this. Let's look at Chaos Visual Debugger. And this is usually, if people have watched my previous presentations, you will know this is like a very common gotcha for other studios, because that's usually like the hidden world that you don't really think about. And then when it's time to ship, you realize like, oh no, like it's horrible. And I always recommend people check out how your game looks like in Chaos Visual Debugger. And this game actually looks quite good. It looks like this. I can actually open up my Unreal, and here we can see Chaos Visual Debugger, and this is the whole map. And as you can see, it has not much going on. I don't see any like complex physics. Is it in here? Like, all right, that was the complex. So here's the simple ones, and like they're all quite nice shapes. It's not that much on it. Like this is actually, I'd say, quite good. So not too bad, not too bad. Okay, so it looks like there are no 8 slots in this game. And you can also verify it if you look at Unreal Insights. Like there's this timing regions for level streaming. And there you can see the names of the levels that are being streamed in. Like here, like I don't know if you can read this with my mouse, but it's basically like L_train objective_arrival, which is kind of like a point of interest or like a sub-level name. And usually when you're doing world partition, you will see the streaming cells names, like streaming in and out constantly. And I only see these in the beginning, basically confirming my suspicion that there are no 8 slots. But even though there are no 8 slots, if I open another capture over here and I just look at the frame time, it's actually quite good. We can see here the game thread tick is taking 4.3 milliseconds. Oh, very nice. We can see here that the render thread, if we ignore the waiting for the map occlusion results, that's taking like 5, 6, 7 milliseconds, 9, not bad. And then if we go down the RTI thread all the way to the GPU graph, and even the GPU frames are like under 16 milliseconds. So it's actually quite good, even though it's not using kind of like the best practices that I would tell them to like normally use like world partition and 8 slot. So I was actually quite impressed. But I'm not going to be on a stream and just look at a capture and say, I couldn't find anything. And now now I don't have to be on the stream anymore. So I thought maybe I could check out other stuff like related to memory or object creation. And I was super happy. I was super happy to see that the game, the captures or the development build, I got was made with Unreal 5.8. because I just added a counter in 5.8, which I mentioned in my previous presentation, for UObjects. And I'm actually a little bit embarrassed that we didn't have it before in Unreal Engine, because I think UObjects is a really essential counter for anything that's happening in your game. We used to have an old system they had to like turn on a global define for. It's like, oh, it's a mess. So I just added it. So now if you start your capture with dash trace equals default comma counters, or any channels that you want plus counters, you have now UObject count as one of the channels. And I love this because this is such an important number. It shows you like if you're well above what I would consider like a nice UObject count. I would usually say for games, if you can keep your UObject count around 100,000, you are like gold. That's like a really, really nice low number. And if you're around the 500,000, like it's kind of common in games, you can get away with it. It's kind of okay. I would be happier around, like closer to 100,000 than 500,000. If you go to 1 million, you might be doing something wrong. And if you go to 2 million, it just crashes because Unreal just can't handle anymore. I talk more about this in my presentation, Profiling with Pirates. And if I open this capture again, and let's zoom out and go to the counters here. So here we can see UObjects. They are being spawned quite continuously. It's about 120,000, which is actually a really good number for like a game with such a big map. So I'm actually, again, very impressed. This is really good. What the hell? What's happening? And you can see here every time, like there's a marker here also for garbage collection, and you see it lines up with the UObject count going down. So there's a bit of like UObject kind of spamming going on during the round, and then they get destroyed. And if you want to see the effect of it, we can actually zoom in on this area over here where the garbage collection is happening. So garbage collection has two important phases in Unreal. We have the actual like reachability analysis, which is like one frame. Here you can see, funnily enough, they're still managing, even during the garbage collection, to stay on frame time, which is amazing. So this is why it's good to keep your frame, your UObject count around 100,000, because you can actually fit it in a frame. So they managed to do that during the reachability analysis. And then there's a second part, which is like the garbage collection keeps going over several frames. That is because it is doing the incremental purging of the objects. Like we have all the objects we need to destroy, but it takes time to destroy them, and we can only destroy them on the game thread. So we're doing incremental 2 milliseconds every single frame. And you can, of course, adjust this in your ini files. So this is stealing basically 2 milliseconds off your frame time for like 7, 8, 9, 10 frames. So not a huge thing because they're still able to keep their game on frame time. But if they wanted to kind of look into it, check out like what are these UObjects that are constantly being spawned, because we see here it goes from 122,000 down to 115,000. So we're destroying 7,000 UObjects every minute. So that's just 7,000 UObjects that we're just spawning just to destroy them again. And this couldn't easily be gotten around by, for example, using an object pool. Yeah. Then you're basically kind of like maybe spawning 200 or something like that. But you only pay that cost once. Then I wanted to see, are there more objects being spawned? Maybe there's a memory leak somewhere, or like they're basically spawning UObjects and then just keeping a reference to it. So I turned on gc.collect garbage every frame. And this is what the command looks like. You just spam it into the console and development console, gc.collect garbage every frame, _1. There's also a console command you can set in your ini file or even as a startup argument with the -exec cmd. So I did that here, and you can see here with the bookmarks, it will make a little line down. You can see here garbage collection every single frame. I don't like the lines going down, so you can click this tiny little white triangle here to turn them off. This is like a little quality of life feature that I use a lot. And if we zoom out even more, a lot more, we can actually see that during the level, it starts at around 115,000 and it ends at around 117,000. So we have a few more, couple of thousands of UObjects more than we started with at the end of the round. Not too bad, but we should look at actually what the memory is doing. So let's check out this. So I made a memory capture, and actually if you look here, the blue line here, this is the tracked memory with the new memory allocator tracker with stacked and everything per allocation. in Unreal Insights. And let me actually show it to you. Is it this one? Yeah. So here, this is when I start the game with dash trace equals default comma memory. And you can optionally also add merdera comma asset merdera to see if an allocation was made because of it was loading an asset. It will tell you can group it by assets, which is quite cool. I talk about it in my presentation. What was it called? It's on my website. It was called the new features of Unreal Insights. And then I talk about how to use this tool properly. And it's like I go through this tool for like an entire hour if you want to learn more. But here we can see total allocated memory. I usually just look at what this blue line is doing. I kind of like ignore the rest for now because that's the LLM, which is also important. But this one is like the cool new tracking feature we have. And it starts off at 4.7 gigs, and then it kind of like starts rising until it kind of plateaus around 5.16. So that made me kind of think, like, is this a memory leak? So we can actually check that out by, you know what? Actually, I'll show you how to do it because I think this is a cool thing cool skill to know. Basically, I want to know everything that was allocated during this time here. I want to see if it was released at the time that this level was unloaded, just to kind of like see if we're leaking anything. So I'm gonna turn my investigation mode into memory leaks, which is a really cool feature of Unreal Insights because it gives you A, B, C. And those are 3 timers. You can type them in manually, but I like to just like drag. If you make a region, it will move A and B towards that region. So I want to see everything that was allocated in this time between A and B. So after A, but before B. And then we can put a third condition, which is, and that was only released after C. And you can see here in the description, so you don't have to memorize this every time. It says here, identifies allocations allocated between time A and B and not freed until at least time C. And then I would run a query, and it will give me all the allocations, but it's just in a flat list, and I can't do anything with that. So I want to say, just give it to me by call stack. Let's do it by allocation call stack. And now it shows me that 408 megabytes were allocated by this runnable thread. So not by the game thread, by one of the worker threads. And you can expand it one by one, but I like to just right click it and click expand critical path, or even more often I just click R, which like fits well with my pirate costume. R gives me, it helps you remember. So here we can see that all of this memory that was allocated and not released, even in the next round, is happening in texture 2D streaming. That's interesting. Do async create with new MIPS. So I looked at the source code and I was like, there's a lot of source code. So I asked Claude, what does this function do? Because I don't have the knowledge of everything in Unreal. And basically this is telling me, oh, this is the texture streaming pool in Unreal. Okay, that makes a lot of sense because there's a streaming pool in Unreal and it's conservative, meaning that if something gets streamed in, it won't get streamed out unless we kind of like overfill the bin, or like, once we hit the limit, we start unstreaming out the textures that were the longest times we actually looked at it. And I wanted to make sure that it was actually working properly. So there's this command that you can turn on, a cvar called r.streaming.drop_mips equals 1. And now, instead of just having a MIP that you streamed in memory, just in case we need it again because the pool isn't full yet, it will immediately drop any MIP that isn't currently being rendered. And by doing that, I had a new capture, and it actually looked like it was not a memory leak. And I actually have the capture here. Let me see. Here we go. And it's a very flat and beautiful line. This is basically what you want to see in Memory Insights whenever you make a game, that it just doesn't rise. So you can see here it starts around 4.62 and it ends at 4.54. So the memory line is super stable, super healthy. Like, of course, it varies a little bit when you go between rounds and stuff. So I tried my best. I turned on the lantern. I looked inside. Come on, lantern. I was like, let the Hitch Hunter help you, Tom. It's okay. But honestly, I didn't see much that needed help with. So I only have one question now. That is, you were using no world partition streaming, no H slots, but the game's performing amicably and under memory. And if anything, you could actually reduce the size of the streaming pool, and because it took multiple rounds for it to fill. And yeah, figure out the U object spamming, but again, it wasn't really affecting the frame rate. So how did you do it? Tom, tell us your secrets.
Right. Well, first of all, it's not just my secret, right? Also, of course, the team Evil Raptor has done a lot of work, and I've just kind of helped out with the optimization a little bit. So I guess today, what I would like to do is maybe go through some of the optimizations that were applied in various areas, and also explore maybe some, like doing a little bit of auditing on one particular map that I would have open now. So you can actually go to my screen share as well. And just, we can have a look at a couple of features and maybe see like what could still be improved more. Like I did a little bit of roaming around the map before the stream, found some things and then intentionally have not fixed them so that we would have something to look at, including actually that streaming pool, which is indeed just too large. It could actually be reduced. And to briefly answer your question about like why does it not need world partition and HLDs or H slots? It's actually so the map here, you can actually see one of the maps. They're not necessarily enormous. So here maybe you can get a better scale of it. Of course, there's a lot of fog that you don't see as much when you're above it. It's like 1 by 1 kilometer should be roughly the size of these maps. And there's a lot of asset reuse. And there's also a lot of rocks. So for example, a lot of these rocks are just the same mesh reused in multiple ways. And they have there's only a few variations on the materials. And the same is actually true for a lot of like the wooden structures. So if I just look for a bunch of like wooden structures, they'll have like one material like wooden beam, maybe wooden plank. And you'll see these same materials used in like 100 different mesh configurations. And one of the ways that Nanite works is that it doesn't instance based on geometry anymore. It just does it based on the material that you apply to it. And so you can actually do a lot of instancing and doesn't even have that many draw calls if you just are able to reuse your materials in good ways, in clever ways. So I think they did a good job with that by just being sparse with their assets. And also it's actually a stylized game. So I think a lot of people will probably wonder like, why is it even Nanite? That's very surprising. And to be fair, when I first got on the project, I was also a bit surprised. They also have virtual channel maps. They also optionally have Looman. Of course, you can turn that off if you just want more performance. But they have done some work to optimize that as well, that it doesn't like tank your performance. But of course, that's still a scalability option, like a graphics option. You can turn it off if you don't want to, because the game is really high-paced and very frantic. So you might not even notice all of the beautiful bounce lights or reflections if that's your play style, but it is available if you really want to. And so I guess also it just has a lot of like natural open spaces, and it has a lot of, again, these rock walls that also have really great occlusion for everything that's like could be behind it. And Nanite does a really good job with occlusion culling. And actually, you did say that, for example, that you could see whenever the fog was disabled, that you would see a lot of these particle systems, and that's true. But I think in some cases, at least, what does happen, show flag dot fog 0. What does happen is, for example, this fog smoke right here, it only animates really in the material, so it has sort of like texture padding, but the particle system is actually paused using effect types, like the Niagara effect types, which you can use or you should absolutely use for culling and pausing and throttling your particle systems when they're either like far away or off screen. And so it's not actually simulating anything anymore. And I think this happens for a lot of other effects as well that you might see in a distance. They're just sort of paused, and it's just at that point a couple of like static sprites that don't take up as much resources anymore as if they were still performing the full like Niagara simulation.
Yeah, that's very clever.
Actually, there's a lot of other things also. For example, the lights. They do have like the light distance fading, which you can show off as well a little bit. We do a bunch of other stuff with lights because, again, it's a stylized game, so they don't need like hyper-realistic lights, which require a lot more size to like look good. But I'll show that in a sec. I guess we should maybe first go ahead and have a bit of a look at the streaming that we do use, because there is no like world partition, because again, it's not necessary. And in fact, it would just make things a little bit more complicated if we try to do world partition, because then we would have to deal with the components getting added and removed. Now, of course, these days we would have a fast geo streaming plugin, right? That's no longer relies on things like actor components, and instead it just has a more of a lightweight representation when you stream in a static mesh. I don't think the project uses this yet, because the game it is now on 5.8, and they're moving with every version, but they already made a lot of these maps well before also fast geo even existed. So not everything is done and enabled yet, but again, the game is still in early access, so I'm sure that by the time it's in full 1.0, they might have it enabled, and that would then mostly affect and further reduce the loading of the initial load screen, right? Because we don't need it during streaming. So let's have a look. Maybe you could do a little bit of the Nanite streaming, because that's another thing that by default, Nanite will allocate a lot of memory, but this is a stylized game, and so it doesn't actually need all that much detail. And I mean, you could argue it shouldn't necessarily need Nanite per se, which is probably true. You could get away with it, but then if you want to use Looman and if you want to use virtual shadow mapping, you might as well use Nanite to get the best performance out of the others. And we got pretty decent performance out of it already, and I think we can still get even better performance from it, because one of the things that they rather still have is things like masked foliage, which is usually a bit of a sin, right? If you just go to, may have gone too fast, like Nanite visualization, pixel programmable, then we can actually see, for example, if something is masked, it will show up as red. So all the foliage, well, not actually all foliage, but most of the foliage is still showing up as red. And so that will actually add some cost to Nanite that we could still improve further. But to show, first of all, the triangle detail, it's not actually all that much if you just go through the map. You might have seen some of the rocks, but also that detail is not that crazy, and only when you are really zoomed in. And so it doesn't need all that much like mesh data. And so if we just look at something like stat Nanite streaming, and maybe I have to resize my view a little bit. I think at the moment we've allocated somewhere around 256 streaming pool size. So that's already half of what is, I believe, the default for the Nanite streaming pool. And we only use about 17%. And so this can really go up if you maybe go through the world really fast, or if you just toggle between different zones, because then it needs to stream in new pages as fast as possible, and it might have not unstreamed other bits. But we really don't go over or even near the 256 megabytes. So that is another thing that it can actually be reduced. And again, it's another thing that I intentionally didn't fix going into this. But under ARDA Nanites, and I always just add a space bar if I don't know the exact word order anymore. Streaming pool, you can see r.nanite.streaming pool size. We can set it even to maybe 128 or 64, depending on also the other levels, right? You probably just configure this once for your game, and then make sure that all of the levels run within it. But these days you can actually change that runtime, so maybe you can have one pool per level. That could be possible. But you should maybe have like a consistent VRAM usage, right? That not one level certainly can't be played by someone that has 8 gigabytes of VRAM, because that would be a bit weird. So you have to optimize for the worst case. So with that, we still only use like 21%. So we could continue to keep going down with the Nanite streaming, because we just don't even need that much, because this is such a stylized game that just doesn't have a huge amount of detail. Oops, I'm still in the other focus. And then the other, so stat none, just to clear that. Then we have more. We could, for example, the virtual shadow maps. By default, again, I believe on Epic scalability at least, that also allocates something like 512 megabytes of memory. That's another thing we can get away with, like much lower resolutions. So that's another thing that we can tune down quite a bit. And the same with the texture streaming. Like by default, that's maybe on like 1 gigabyte or 2 gigabytes. But I think in our case, if we just look for stat streaming, then we can also just see how much memory we're actually using. So we can see the required pool over here is only like somewhere about 10% of what is available, which is the 2 gigabytes. And also, if you go through the world, it doesn't really increase all that much. It might go up slightly at certain bases. Also, maybe, of course, if you play the game, we might have more particle systems that would get loaded in, enemies that would get loaded in. So that would increase the pool requirements a little bit. But that's another thing that could really go down quite a bit. And if you want to maybe check out like how much memory is being allocated, or VRAM rather, is being allocated, one really interesting tool is under Tools, they render Resource Viewer, where we can have a look at a bunch of the GPU resources that are being allocated. So here we can actually see the Nanite memory. So it's nicely categorized with Looman. We have some miscellaneous, like also global distance fields, take up a bit of memory that we could maybe reduce and optimize. But then also, and here actually we see the shadow. So this is the shadow.virtual physical page pool. So that's what virtual shadow mapping needs. And at the moment, it needs that 64 megabytes. So that's not that crazy, considering the default is a lot higher for virtual shadow mapping. And we should be on like epic scalability for the shadows. So it will go down even further if you go to like lower medium. And on another thing I think that's interesting here, which I just noticed also in preparation of this stream, is that I also saw this game texture, and then I didn't see what was coming behind it. So this thing right here. So we just scroll into that or double click it. We can actually see that some kind of T lighting O2 was taking up a lot of memory. And if I can just go and click on here where we just see all the resources, I can actually see that it was taking up 66 megabytes for some reason. So we can just Control B to go and jump to that texturing content. And if we just open it up, it's a flipbook. So it takes up, it might take up a little bit more memory than a usual texture. However, it had a bunch of issues, I would say.
It's 4K. I actually also managed to see it in the memory profiler. I was looking at like what is in memory right now, and this was one of the biggest. It was the biggest texture basically in the game.
Yeah, right. So I think it's interesting in a couple of ways. And I mean, first of all, it's probably not like the most efficient use of like also the last row where it only uses like a little bit and also doesn't even use this. But there's like also no MIPS, which might be a bit of an issue for streaming. It's also uncompressed. And then I actually at first didn't even notice, but it's not actually 4K. It's 4K-ish. It's 4098.
Ah.
So that I didn't notice this at first, but it's actually imported at the incorrect resolution, which is preventing it from getting streamed in because it's not a power of 2 texture. And sometimes what I've seen before as well is that people just enable like never stream on this, and then it just always loaded into memory. But that was not the case in this instance. But it was just accidentally someone just imported this the wrong size, and so it is just always in memory.
Yeah,
at least it's always in memory. Yeah,
4096. So it's off by 2 pixels.
Yeah, so it's a little bit off. And then it's also just it's loaded also because it is actually referenced in some way. So this we can just go into the reference viewer with the lightning strike, which is probably some kind of player ability. We also have some curse strike, and if I just click on this, I can actually see some like cryptic token that might be a blueprint that would be in the world. That could be interesting. And then we have this BP Canyon game instance. So the game instance would always be loaded, right? That's just when you load in your game. That's the game instance that gets started, and it won't be destroyed until your game executable actually exits. And so I guess that is referencing this cryptic token. And so that means that even in the main menu, you will probably have that lighting O2 texture in memory in full res. And so, I mean, of course, maybe the Canyon game instance shouldn't have to have a hard reference to cryptic token in the first place. But the real issue here is also that it's just the wrong resolution. So that's one thing that you can also find. And I found in the past also where maybe certain games were using like marketplace content, And then you can also get all kinds of issues from people just maybe checking another stream because that looked better in their demo sample, or they again have like 8K resolution, or like just other settings that just maybe look 1% better just for the demo purposes, but it's not actually good for game development. And so I've seen other cases where there was one mega, like a 3D volume texture that was like 1 gigabyte. It was just always loaded for some kind of like really cool, it was a really cool explosion, but it was definitely not worth 1 gigabyte of everyone's VRAM at all times.
I love this texture as an example because it's such a great example of like a very easy to do thing. It's just, click export, type in the wrong number, and then go and not notice, and then how much of a cascading effect that can have in terms of memory and performance.
Yeah, exactly. So
the lack of MIP.
For sure. Yeah, so these are also just real examples that just are going to happen. Like obviously nobody intentionally would do this, but it just happens. And then at some point you just have to go through these tools and then just find out, first of all, that the tools exist. And actually, Render Resource Viewer is not even that old. I mean, back in the UE4 days, we didn't have this.
No, the Render Resource Viewer is really new, actually. And I was wondering, this is actually a really useful tool, but it's a shame that it only lives in the editor because the editor has a lot of overhead stuff. So you can actually get the same results in a package development build in the console if you just write rhi.dump resource memory. And there's even like a encompassing command called rhi dump memory that might give you like a text version of this same window.
Could you reopen that window real quick, Tom? I had somebody in the chat wonder where you found that.
Oh, it's under Tools and then the Render Resource Viewer.
Thank you very much.
Yeah, it might also be under like mem report. If you do maybe mem report -full or something, it's probably also under there. What Ari was talking about.
Yeah, I think it's in there, maybe. But if it's not, just write rhi just dot dump memory.
Yeah, exactly. And also I'll put all of these, I'll try to put all of the console variables and little things that I type out today. I'll put it on that optimization landing page. If Dan can also share that, because that would probably be very useful, because I think I will just be dumping a lot of little commands and stuff during this stream.
I checked base engine and it is indeed dumped when you do mem report -full.
Okay, nice. So yeah, so we have so we did the texture streaming, the virtual shadow map. It could actually be probably reduced as well. Let me actually show that one too, because well, we've done a lot with streaming, I guess. So we can just move on to maybe some like Nanite optimizations that we've also done, because there was. So even though it's not like a lot of triangles, there were still like again like more issues that can super easily happen. And that might also be happening in your game as well. And so I feel like often people talk about things like overdraw when it comes to Nanite, but then people might also always be wondering, so when is actually overdraw? When is it bad and when is it okay? I guess like, for example, with the foliage, it could be, can get pretty bad quite easily. But I have a couple of good examples of where overdraw went really wrong. So let me open that, because I got it as a screenshot from a before it got fixed and after it got fixed. So this was a before view of one of their maps. It's actually one of the other canyon maps that they have. And this isn't a common thing that can happen, because this is just a bunch of rocks kit bashed together and merged into a single mesh, and then that mesh getting copy pasted a bunch of times across the screen. It might also be using PCG, which they are using in some other places. I think this one all were manually placed, but there are other areas in this map that are PCG. And you just get a lot of overlapping geometry. And the reason why this is bad with Nanite is because with the vis buffer, so that's the first pass that Nanite really does, it basically just tries to, with occlusion culling, tries to figure out which cluster is going to be visible. So the clusters are actually...
So the clusters are intersecting, because, so that's the depth basically, because I'm trying to wonder, like, how could people get away with it if they want to want to place instances?
Yeah, so the thing is indeed based on the cluster. It tries to figure out, okay, which one is going to be visible and which one is not going to be visible. But then it doesn't always know. It can't always be sure. And so in that case, Nanite is like, GPU figure it out. So it will just render both. And then as a result, one of those, based on each of the pixels, like here we'll have some of these clusters that are overlapping. Some of the pixels are going to win from one cluster and some of the other. And then it will, based on whoever won that call, basically that draw call, it will assign a material ID to then be used later in the Nanite base pass, where it will read all of those material IDs per pixel and be like, okay, this is material ID belongs to this wooden plank. So I'm going to render this pixel with the wooden plank. So that's really why Nanite overdraw then happens. So also if you have like really actually super low triangle density and therefore really large clusters, then you can actually have more overdraw. So if you like think that you're super optimizing your meshes by having like super low triangle detail, but you have a lot of like those clusters overlapping because those triangles and those clusters are so large, you might actually have more overdraw. So you might be rendering more pixels in that way than if you were just have more triangle detail, because just Nanite is really good at just chugging through a lot of triangles. But if it doesn't know which pixel or material is actually going to win, it just renders both. So that could be actually a downside. So then actually, let me just show you, because I only showed you the before, which is a really bad example. But then this is what happened after I optimized only one mesh. And that was this. So you can see that it's significant reduction in overdraw, because that particular mesh happened to be used like just in this entire rock face, right? That's why it was so extreme. And I believe on this particular view, it was somewhere around 0.5 milliseconds reduction in the Nanite vis buffer, which is pretty massive, because we only had like maybe 1 or 2 milliseconds in total.
And considering it was just one asset that had,
and it was just one asset, and it was, of course, it was a particularly bad one in terms of like overdraw. So this was one of those assets where it really was just a lot of like rocks stuck together, and then the inner triangles were never culled. So what I just did, it was the most brute force way possible, because I'm also not a Blender artist. So I just exported to Blender. I just did an orbit view, and I was just like control selecting all of the triangles and just going around the whole mesh. Control I to invert selection and delete all internal vertices. So it was like 5 minutes of work, and then we had the mesh on the left now. So it was definitely worth it, because that was a pretty big win.
And very quickly,
That's really
for folks who don't use Blender, the reason that works is that Blender goes based off of view unless you go transparent or wireframe. So he's specifically selecting only the triangles that he can see, and then everything else that Blender can't see doesn't get selected, and that's why.
Right. Yeah. Very important detail. Yeah. Exactly.
Yeah. I do wonder if you could have used the modeling tools instead of Unreal, like using a Boolean operation, like using Boolean and. I haven't used them myself that much, but I think there's probably something like that you can do to merge meshes inside of Unreal.
That's probably a much smarter way to do it. Yeah.
Zeef just commented that there's a tool and engine in the modeling tools to do it easily as well. I think it's called Jacket.
Jacket. Well, that's something. I mean, there's more meshes to do this on, so I'm going to try that one out for sure. That's very interesting to know. And so there was other cases as well. Like I think it would be nice to show one more case maybe. So this was another one, same mesh, and then after reducing it, it was just this. So it still can be improved, but now at least we removed quite a lot of the glowy bits of overdraw. And in that particular case, it was like 0.2 milliseconds on the vis buffer, but still, only one mesh. So it was a pretty nice win. And so that just kind of happens when you are kit bashing, or I mean, especially when you're kit bashing. There's other cases. I just want to show off one more. actually dynamite. Oh, there's no dynamite in this map. How could that possibly be? Let's see if there is one on this map. Otherwise, I'm gonna not bother with this. There was more examples of like overdraw, where they had a wooden crate, and then also put a hay bale inside of it to have like a little bit of a hay inside of it, but the rest of the triangles were not like destroyed. So as a result, you just have a hay bale inside of your crate, and that also just became a bit of a big glow. Now it starts to matter more when it's like, of course, filling more of your screen. So a small crate in the world is not going to tank your performance. It was a lot more serious with things like these rock walls, because they are just really large. So it's not always necessarily immediately worth fixing. But I think with also like the that git bashing, it's just good, especially if you have something like that jacket tool, you just get all of the triangles on the inside out that people would never be able to see.
And it's also important to note too, right, that like in most cases it's more of like a death by 1,000 cuts thing rather than like here's just like the one big wound, right? So like little things like that, depending on the use case, depending on the need, may or may not be worth doing, but they do help as each thing adds up in a project.
For sure. Yeah, exactly. They definitely add up over time. So there was another case actually with, let me have a look at, for example, these lanterns, which was, again, Nanite related, but it was just a very simple thing that people can do with their blueprints. And this one I did fix, so I can still show you kind of like where it was or kind of what it was doing. But essentially, it has this, it had this light underneath a chain. And what it wanted to do is have the ability in something like construction script to then be able to change the light of this little glowy material. And one way to implement this, which is the easiest way to implement it, but not necessarily the best way, is to call functions like something like set scalar material, set scalar parameter value on materials. For example, this one. Like this sort of stuff it's super convenient because if there's not a material instance dynamic on the mesh at the moment, such as the material instance, then it will just create one for you, apply it to that mesh, swap out the old one. And now it's a dynamic one where you can change the parameters on this particular instance of this particular light, but it won't affect any of the other lights. So you can have like unique colors per thing. And then, it's really cool that you can do that in construct script, which is run whenever you're like placing a light. It will just run that piece of code and you can just change the light color and it will save it in the map and it's all cool. But the downside is now that this become a unique draw call for something like Nanite. It can no longer use that same material shared across all of these lights and just push it through in one draw call. It will now do one draw call per light, basically, per light mesh, I should say. And it gets worse because this particular mesh actually has 3 material elements. And so, I mean, first of all, these could be merged, right? This could just be one. But then we only really want to have the light color change on this MI emit lantern default. And the others don't even need to be a material instance dynamic ever because they're not going to have to change the light. And so that's another case where certain convenience functions can really bite you because now, without you realizing, you've made 3 material instances material instance dynamics rather than just the one. And you've done it for every light in your world when you looked in the map. And so in that case, it was actually, let me just pop up my own numbers. So it went from 488 draw calls in Nanite. And if you're curious how you can find it out, let me just show you. The shorthand for that is Nanite stats. And that will show you a bunch of information, which again, I have to just squeeze in on my screen. It's just, that's what you get when you upscale your windows. Here you can see the shading bins. So that's essentially the draw calls of Nanite. In a way that we now have like 247 shading bins, so draw calls for Nanite, and about 135 of those are not currently in view, and so they don't contribute to anything. So here we can now see, now that we're looking at the ground, we can have we actually have 244 empty draws, which basically means a draw call was sent to the GPU, but then no pixel on screen was actually using that material. And that is just how Nanite, again, works differently from what a lot of us are used to, in that it just sends out those draw calls and it'll be like, good luck, GPU, figure out if it's actually doing anything. Of course, it can, these days, pretty easily call it and say like, okay, there's no pixels. Okay, I'm just going to discard it. But it does still send it out to the GPU.
The reason for it is because the GPU, like Nanite, is fully on the GPU. It doesn't do a round trip to the CPU, which means that you can basically save a round trip because you need to do the fences and stuff. But that means that we need to do the calling fully on the GPU, which means that we don't know on the CPU whether it needs to be rendered or not. So GPU needs to figure it out. And that's, if you send it work and it doesn't render anything, it's an empty bin.
Yeah, exactly. So that's pretty important detail. So actually, for the more visual on the wrist, I also made a lesson on this in the course. But so here we from 488 draws to 174 in another level, which was I think a forest level. So it had quite a lot of these lanterns because we had like 3 instance dynamics per lantern. And so we basically cut the whole base pass in half. Which is kind of crazy. I was not expecting that difference to be that enormous. But yeah, so that was a pretty major win on that front.
So an interesting message in chat, maybe that might be worth kind of bringing up here, is someone said this might also be a good case for custom primitive data instead. That way you won't even need a dynamic instance.
Yes, that's what we've done here. So exactly, that's the change that I made is in the case of this particular implementation, like going for the dynamic material instance is just not really the way to go. You can actually use custom primitive data, which is how it got updated now, where you can still have a per component change, but now that data lives on the components primitive, and that stuff is still uploaded to the GPU, but you no longer need a unique draw call and a unique material instance. So that's definitely one way to go about this. If you need that flexibility, that's definitely better. And also, if you actually don't need it, you could also just assign and just make a couple of variations of the different colors that you're actually going to use in the game, because usually these things come from like, oh, it would be so cool to have it be super dynamic, and then you end up with like 4 variations in your entire game. Maybe just make 4 material instances in your content browser and just assign those to your different blueprints, or to, like, again, in this maybe construct script, you just assign them. Then you just also don't even need to bother with something like custom primitive data. This is really if you actually want it to be super dynamic, and usually it doesn't need to be super dynamic. Yeah, you can just sometimes get carried away with really cool tools that you end up not needing that much.
So something that might make sense for that is a light color or intensity that you control versus something that's kind of static but different.
I mean, so if you really want, if you need, so if you could still like change the parameters on the actual light. So for example, this one also has an actual point light where you can have the intensity changed. But often you might only have a few variations on this blueprint in your world based on maybe different maps might have different variations. Also, if all of your lights in your map have the same color variation, you might also just use something like material parameter collection. And then it can just grab the data from that once as well. Then it's also shared between all of them. So there's always 1,000 ways to implement something. Sometimes the coolest way is not always necessary and adds a little bit of overhead to whatever you're trying to do. I think so. That was a couple of the Nanite optimizations that we've done. There's always more, but I think on the vis buffer, we're mostly around the 1 millisecond, and the same with the base pass, like 1 or so millisecond on my PC, which, to be fair, is a 3080 Ti. So that should obviously run Nanite pretty well. But those are, I think, are pretty decent numbers, and a lot of that cost is still sitting in something like the foliage. So if you have a lot of foliage on screen, which again is using the pixel programmable, which I showed like a little before, which is basically the slow path of Nanite. So the more red your screen is, the worse performance is going to be. But I talk a lot about foliage in another video as well, where I basically go through Far Far West for like an hour, and one of those topics is actually foliage. So you can probably better look at that video if you're curious.
As a quick summary, though, for it, like ideally, don't use the masked material for foliage, correct?
Yeah, that's kind of like the worst case for foliage, usually. I mean, we're still getting decent performance with it, also because a lot of the foliage is actually pretty low to the ground. If you have like a ton of trees, it's going to get significantly worse. But as you can see, like there's a lot of, I mean, not all the maps in this game are on like these desert plains. Like some are actually in forests, and then you have to do other tricks like maybe disable pixel programmable at a certain distance, and then the mesh becomes like non-masked. But there's ways around this. I think also Ari talked about this as well in one of the talks with Matt about having like cutouts for your masked materials. I mean, to be fair, the ideal world, you just don't have it, or you don't have masked. You just have it modeled out as far as possible.
Yeah, it's just cheaper to throw vertices at the problem to a certain point, rather than trying to either using transparency or even masked. Because like we've made Nanite so that it can handle basically one triangle per pixel, which is like ridiculous. And mask is just it uses a much slower rendering path.
Right. Yeah. So actually, let me show Nanite's show stats. So the Nanite stats is actually how you enable it, but I think just to disable it or you don't remember it, also our.nanite.show stats 0 also just gets rid of it. I think another interesting thing is like lights, because that's super commonly an issue. And that's also where this game is a little bit different, I think. Not in any technical complex way, but actually in just it being a stylized game. It doesn't really need the lighting to be super realistic. And so one thing we can get away with is a different lighting fall off than what's the default. So for example, maybe if you just jump to these carts right here, the standard fall off is like the inverse square fall off, which I will just show you to have a better idea of what I'm talking about. So the use inverse squared fall off is the default way that light sort of fades out. If I just go to lit and then detail lighting, maybe you just don't even see that much because we're in the sun. Here you can see it a little bit better. And the thing with that is it's actually a very soft fall off, which is probably very nice for a lot of games, but not always necessary. And I think also for a lot of like gameplay lights, it's maybe a bit too soft and it's just too subtle. And as a result, you get these mega cones. Like by default, if you have, and I will show you what it looks like with another example in a bit. You have these giant cones or these giant spotlights. And after maybe 60, 70% of that cone or a sphere, you don't even see the light influence anymore, but you're still paying that cost because you're basically paying like, this is the light projection cost that you're paying for this light. And so if your light projection is like much larger, but it only really influences this area right here, you're still going to pay for all of this, depending on how big the light is on your screen. And so in this case, they already turned it off, and then of course you have to mess with the intensity a little bit, and also when you turn off this, I hope you can see it, the inverse squared fall off. You also can tune the light fall of exponent, which is 8 by default, but then you tune that down to 1 or 2 or whatever feels good. And then you get a much, I would say, tighter light cone, which naturally is going to be cheaper in a couple of ways because it's small. You can make it smaller at that point, of course you have to make it smaller, but you get the same like visual influence. The fall off is more harsh, but that might actually just look totally fine and might even look better for your game. And also the smaller your cones, of course, of fewer shadow resolution you need, and because you need fewer virtual shadow map tiles or pages. And you have fewer invalidations because anything that falls out of this cone won't invalidate that shadow.
Lights is one of the most expensive things you can basically do in computer graphics. Like, well, I say that, but there's so many other things you can actually do. But one of the things that, let's say, games often shoot themselves in the foot with, because you need lights anywhere. So if you put in too many lights, then like they're going to be casting shadows, so they need to basically, render the whole scene again to figure out the shadow map for each light, and then you can like put it too big. So like there's all these optimizations, like you mentioned, by reducing the fall off size and by turning off cast shadows. And that's why technologies like megalights are super cool, because they just introduce a fixed cost for lighting and shadows in general, and then it uses like it fires out a very set number of rays every single scene, so it's temporal and it accumulates. That means if you have too many lights, it's not going to affect the performance, it's going to affect how they look, because then all these lights are going to be fighting for like these set amount of rays they're basically firing every frame.
Right. Yeah. And so we don't use megalights, by the way, just
No, it's very new.
if people are exactly, just if people are wondering, we're not using megalights. And also I don't think we need megalights per se, again, because we can fix it in a lot of other ways with like these simple techniques. But yeah, megalights can be pretty cool if you have like a ton of lights and you're running on. I guess also in this case, this game also has to scale down quite significantly. They even want to have it run on like DirectX 11, and then suddenly things like megalights, but also actually Nanite don't even work anymore. So that's an interesting challenge that maybe we can talk about at some point in the future, because scaling down is always a huge issue, especially scaling down to DirectX 11.
Yeah, sorry. Can you turn on the Nanite stats again? Because we got a comment from Super Danger Goose saying that they noticed that the Nanite stats look different from the normal stat system. They're harder to read because they don't have a gray background. And there's actually a reason for that. And I think it's fascinating because I just recently learned it as I'm trying to get a little bit from the CPU and more into like the Nanite profiling, that kind of stuff. And the reason for that is basically what I mentioned before, is that Nanite doesn't make a round trip to the CPU. It runs almost exclusively on GPU, which means that the CPU doesn't know. So this data can't go into the stat system because the stat system has no idea that's happening. So Nanite actually has its own way of rendering its own stats by using a shader. So it's a really cool reason for it, but like, yeah, it's unfortunate that it looks so different from our normal stat system.
Right. Yeah, that's also, if it doesn't show up for you, you might have to enable r.shader prints. That's what that is. So also, if you're looking for like, what is this whole thing? Because virtual channel mapping has the same thing in Looman as well. Like, I think a lot of the modern features have it. So shader print is what you're then searching for if you also need a term to search what those stats are. I've had cases where I think if you do Nanite show stats, it turns itself on, or shows Nanite stats. But I've had cases where I typed out something for virtual channel mapping, and it didn't do it until I enabled that for some reasons. I don't know what was triggering that, but that's why I know that it's called that.
I love this because that is something I never would have considered. It's so cool.
Let's see. Actually, so we have the fall off, right? Which you can tweak, which can have a pretty big effect. And another thing is that overlapping lights is another cost. So if you have the more large cones you have, the more overlap you get, and that would then also be add cost because it has to, well, render the lights in multiple cases. But you also have things like virtual mask projection bits, something along those lines, which gets more expensive the more of those overlapping lights you have in your scene. So there's a lot of reasons why you want to have small lights. And we can get away with it because we have such a stylized game. I think another interesting bit about this is what are the tools? And I'll just open it here as well because I already had Light Mixer open, but it should be, whenever I don't remember, because I often change between a lot of different versions of Unreal. Under Window, Light Mixer, you can search. It's right here. That's another tool that I find super useful. It's different from the Environment Light Mixer, which is, I think, also here. Just search again. Yeah, so don't go for Environment Light Mixer. That's something else, but the Light Mixer. And by default, yours is going to look a little bit different. But you can just right-click and then, again, just type out whatever parameters you're interested in. Like I, for example, have the attenuation radius, stochastic shadows. If it actually already has the use inverse squared fall off, detail mode, max distance fade, and max draw distance. Because this is super useful because now you have just this whole overview of all of the lights or all of the blueprints that might contain a light. And you can just jump to it. And then also it's if you maybe select like a card here, it will also have it in sync with what you selected. And you can just inspect and make sure, okay, does everything have, for example, a max draw distance enabled? Because if you don't, then at a large distance, again, that's one of the things we're doing. We have all this fog, but the engine doesn't know about a lot of feature. So it doesn't know when a light is really not visible anymore, but we can determine this because we know the fog. So at a certain distance, we can maybe have a look at the card and be like, okay, well, oops, I'm going very fast through the level now. At a certain distance, we might see like, okay, now it's no longer going to contribute that much to the scene. So we might as well just call it entirely, not even bother invoking like shadows for it or light projections, and just turn it off. And that's something you can then control with the max distance draw. In this case, a lot of cases, they have the fade range set to 0, which means that it will just pop in. So if you just, with holding down the right mouse button and holding down C, you can actually zoom in and you can actually see it more aggressively. So it's popping in. You could set that actually to some value. I usually start with like 750 and then just tweak from there. You don't want it to be too long because then it's like we have the real slow fade in, and then that might also not look good. But that way you can actually tune that a little bit that people don't notice during gameplay. And of course, you can then further tune it with something like scalability to maybe more aggressively call when it's like when you're on low shadow quality. Because actually, under the viewport scalability, like under shadows, if we set it to like low and medium, it will actually have a multiplier of 0.5, which you can of course change in the scalability settings. It's called R dot. I will just type it out here as well. R dot light max draw distance scale. We just add one more with a clean log. By default, of course, now we're in epic scalability sets on 1. But then if you go to like lower, it will be a half. So then it calls it more quickly. And it's going to especially be useful for maybe like more like less important lights. So I guess you don't want to have this enabled on lights that are like gameplay leading, that are leading the player to some area, because then certainly if it's with the scale, it's like already off, like already culled, and the player can no longer find its bearings. But for like more ambient lights that are sort of like more cosmetic, it can be super helpful. So that's another thing that they do, and then especially in like the fog, right? At some point, it just no longer really contributes, but it would still add cost, even if you don't really see the lights that much anymore. Then another thing, because there's a lot with lights, is, for example, the projectors actually. So maybe certain projectors are over here. So they might even have 2 lights. So they have one little point light over here, which does a little bit of like a bit of a self-lighting of the whole pole, which looks nice. And then you have this larger cone, which actually does have the inverse square fall off already off. However, it's still, it should be this one. This one. Nope, this one. But it still goes through the ground quite significantly, right? It still is going to eat up more cost than it needs. And I think this is it was just tweaked for a general case. Where in certain cases, it's like I'd already seen it somewhere that it's lighting like a church building and it needs kind of a long range. Maybe it's better to just be more conservative. And then on a per instance basis, you can always go ahead and tune like the cone, the light cone of the instance itself, rather than having every one of those be the same.
Luckily, there's not too much underneath, because the cost of lights doesn't scale directly with the size of it or distance. It scales with how many objects basically are inside of that cone.
Yeah, that's of course going to affect it with the shadow cost, but the light projection itself, that can actually be affected by how big your light is.
Oh, really? Wow.
So that's a separate thing from like the shadowing. So of course, there's not really much to invalidate like shadows and stuff, but it's going to affect the other lights. So that's one thing. That's more of a case-by-case basis. I mean, maybe you could just in your construct script like do a line trace or a sphere trace and feel like, okay, this one it's something in the middle this far away. So then I know how to adjust my view distance or my attenuation radius. That could be cool. But the other thing that I just wanted to show is that, for example, and this is like a super old feature, but it's still nice, is something like, wait, I maybe have to just disable group selection. I'm just going to open up this project. So this point light is what I wanted to tweak. So we can actually also set it detail mode to something else. By default, that's on low. And this is also like a super old setting that I think was used for like Cascade a lot, but also maybe on like smaller meshes in the environment that were maybe a bit of set dressing, but not super critical again to the gameplay. and then you can set it to a different like detail mode. So you could maybe set it to medium or high, and then whenever I guess it's going to be under the, if it like loads for me, if it's if you change the effects quality to be low in this case, it no longer matches that. It's no longer in the detail mode, and so it will actually just go to it will actually just turn off that light. And again, this is just a little bit of a cosmetic light. So someone that's on low scalability is not going to care about that little light bounce, that fake light bounce not existing, but it is going to care a lot more about performance. So in this case, you can just turn this off for like small little sparks and flies that are in the map, and then actually keep it on for the higher scalability, where people are going to care more about the overall visual quality, of course. I actually think my editor froze. So I don't know what I did, what happened here. Maybe I moused over the wrong thing. So I'm just going to see if I can get that closed somehow, and then relaunch.
I'll pull the stream down temporarily. Do we want to take?
We have a great temporary stream down. Switch to my screen.
Oh, there we go. Let's do it. And switched.
Oh yeah.
It really is a great.
We have
maybe
another, yeah. So maybe in the meantime, while that's loading, it's not going to take that long, which is another nice thing, that this project doesn't take super long to load. Maybe you can also have a quick look at maybe a little bit of Unreal Insights. I guess also Ari already looked into it a little bit, but one thing that I find is very interesting is to maybe look a little bit more at the collision and the physics as well, because that's another thing where they did a bunch of optimizations. So here we have Unreal Insights, and I guess this is already the fast path, which is already the optimization, but here we have another Unreal Insights, which does not have the optimization. So one of the things that they do, which I think is very interesting, is they have all of these enemies that can roam around the map, like attack the player, and they, of course, usually, like commonly, if you don't do any optimizations on that, that's going to really affect your game threat performance. But in their case, the game threat performance is actually pretty good. So usually during combat, they still have a lot of like time available. So here you can also see that the game thread is just idle, because the overall tick doesn't even take that long. And even here during the end physics is also just waiting on the physics stick. So if you optimize the physics stick a little bit more, then this would again be faster. So it's mostly just spending, well, a little bit of processing time, but also just some waiting time. So if we were to optimize this even further, it's not going to really give us more frame rate on this PC, at least in this configuration. But one of the ways they did this is by just disabling the collision on the skeletal meshes of all the enemies, unless the player actually fires a bullet. And that's because it's using hit scan weapons. So it's not actually launching projectiles that are going to like fly through the game for a while. It's just hit scan. So we just need that one frame of information, like, okay, currently are you going to hit me on my arm or on the head? And then after that, you can just turn off the collision again. And they do this on the skeletal meshes, on the physics assets. And they keep it enabled for the capsule. So the capsule is actually still going to collide. And that's useful because enemies, for example, there's a minigunner in the game that shoots a bunch of projectiles. So he can still hit other of his teammates, basically, of the enemies. And then they can still have friendly fire, which is like a fun mechanic that you can then play with, just running between the other enemies and the minigunner, and he's just going to kill his entire team. That's always fun. And that still works because you don't need that precision of like, did it hit the head or the arm or the legs? It doesn't matter for the enemy to enemy hit detection. But we, of course, care about that precision also for headshots and stuff like this for the player. And so then they enable it. Although by default, one thing that happens is that when you enable the collision on something, it does take quite a bit of time, because one of the things it needs to do is just create a physics state for it. So it needs to create the physics bodies and the shapes, and also needs to upload that to Chaos. And it needs to do that synchronous. It can't do the asynchronous. It can't just say like, okay, you just do it when you can, because we need that information right now, right? We have to do a query immediately. And so that can actually cause a little bit of a hitch. And then one of the things that I have actually from to show off kind of what it looks like in Insights, I just already have a screenshot, is where they have these function, like when you do a bullet, they just enable the collisions. And then you can see here that on the actor component, you have the create physics state, which is then going to create that data and also going to send it off to the chaos physics. And in the worst case, like this was a pretty worst case, but in the worst case, you have something like chaos push data, which you can see on the left here. That's going to process a whole bunch of like collision data, and then it will finally be able to do its physics stick. And as a result, what you get is like a cascading effect, because what you then have is, if you just go back, so this might happen here where we we enable the physics, then somewhere down below, it's going to actually run the physics stick. And then once it's finally done, only then is it allowed to end the physics and actually go over here and run its final updates and then move on. So if suddenly you have this chaos hitch, then your whole game thread is just going to be waiting on all that data to be uploaded, processed, and returned. And so one of the ways that we actually found, and it's a little bit experimental because we just implemented this last week to try and mess with it, is to not call like the default set enable collision to false, and instead just go a little bit more directly into the physics system. And actually, this was not, I didn't come up with this. This was something from Voitos, which shared a bit of I probably should show this a little longer. He showed a bit of a code example, which is why I love people making blog posts so much. He had this like super niche problem. Well, actually not that even niche problem, but I had never encountered it before, where it would just turn off the collisions, but then keep the physics state around. So it just sort of leaves that behind in the world. And then when you need it, it will just grab that data and reuses it instead of throwing all the physics state away. And then whenever you re-enable the collision, it will have to just recreate the whole thing from scratch. Which actually has a side effect, which actually Ari already talked about, which with the garbage collection is because like a part of like a bunch of the objects that were created and destroyed during garbage collection, or like they were destroyed during garbage collection, but created during gameplay is that physics state. Like the more you're shooting in that 60-second window where the default garbage collector is running, the more of that garbage you'd be really generating by just enabling and disabling the physics in the collision. And so this will prevent this, and instead it would just keep it around. And I actually would like to show that in something like the Chaos visual debugger, because I think it's just very cool that these days we can visualize that just so much better than we used to. Because I think back in the day with UE4, it was always like you knew that your collision was the problem, but you didn't have all that much to go on. You just had all your stats, like you could use a stat list, or the object list, and then just dump all your collision shapes by size. You're like, okay, that's a lot of memory, so it's probably bad. But now we can actually see in so much more detail on why something is bad and just fly through the world. So let me go ahead and actually go to Tools, and then the Debug, and then we have Chaos Visual Debugger. And I'll just drop it into another tab. And I guess we can just play somewhere, and I'm going to just spawn a few enemies, and then we'll just do a quick recording of the Chaos Visual Debugger and do a bit of playback. So let's see, we have a little cheat menu, so everyone close your eyes. Super secret. Actually, so you could see that he was still killing his buddy. And maybe I should just spawn one more of these guys, and then he's just going to run around the world, and only when I shoot, he's going to enable the collision, and then after a little bit, it's going to disable that collision again. So let me actually go ahead and enable the recording now. So let me do one more time where I just spawn this grunt. He's going to run up to me. And we'll just do one more for good measure.
It's also much fun seeing debug menus in games.
Yes, and everyone always makes completely different ones.
Yeah.
Okay. I'm just going to quickly stop this and exit.
It's a complete
okay.
aside, but the movement and everything looks really fluid. That looks fun.
Yeah, it's a super fun game, and it runs really really well. Because before I came on, they had already done like a huge amount of optimizations on this game. So one thing that's super cool about this Chaos Visual Debugger is that now we can just play back what we did. And you can either, on the top left, you can just do the camera manager where you can actually see the game that we just played, basically. Or what is also nice is just perspective view, because then we can just inspect like kind of what's happening. And then we can see that the enemy is now moving, but it's all this stuff, all this physics data just sort of stays behind. And it's not updated and not adding any cost of like having to move and update the physics system with all of its stuff until we shoot a bullet, and then you can see that it just jumps to the enemy again. And so again, it just stays behind until the data is needed again. So that's super useful, because that can really use on like 30, 40, or 50 enemies that are roaming the map. That can really add up to a lot of savings on the CPU. And also, I think if you just already recorded that. One thing that I also find is super interesting is that you can see that when it's blue, it's dynamic, and so it's movable. When it's red, it's physically simulating, but I believe it's resting. And then when it's yellow, it's physically simulating, but it's also just active. And actually, now that I'm here, another thing that's I think interesting is that we have this rails right here, which we can see it's blue. So something has gone wrong, because if we are just going around the map, this is actually probably pretty static, right? This is not going to really move after we start playing the game. And we just quickly check it out. So it's like BP rails we can inspect here. And we can actually also see what it's made out of. So we can see that one of these meshes, one of these components, contains like 6 convex shapes. And so this is a little bit confusing, because these really look a lot like just boxes to me. And but somehow they're convex. And so what actually happened in this particular case is that because it's on a spline, it's not only going to just add and deform those meshes to be a spline mesh, but it's also going to deform the collision to become convex. So even though this particular like rail, for example, if you just go in under show or under the little eye icon, we have these, which are certainly boxes, which again, I can just show by going down the list here. They are in fact boxes, but then when they get deformed, they have to be deformed with it. So it actually becomes convex shapes. And so I think there was a good intention here, which whoever made this was thinking, okay, maybe I should just make 6 of them. And then when the rails are bent, we have 6 boxes that are sort of like bending with the mesh, but actually it just becomes convex shapes. So we can probably just, in this case, like get rid of all of them, maybe add 1 box. And then what happens is that whenever we regenerate this, it will also just make 1 of them. So now we have removed like a few thousand collision shapes from the scene. Another thing that this is super common, it happens all the time as well, is that whenever people make blueprints, they actually forget to check like the mobility on all of these things, which is like super easy to just forget about. Or they forget to set it in this whatever component they spawn in like their construction script. So this could be maybe set to movable accidentally. But even though it's set to static now, because whatever we're attaching it to is still set to like movable, we end up having this all be movable. And so what ends up happening is that it gets just added to like a different, as far as I'm aware, a different tree, and it performs a different collision check, because it now assumes like both your player is kinematic and the rails is kinematic. So it does a different collision check than if it knows that the other one is static. So this is happening. This is going to be happening also with like a lot of other blueprints that you just forget to set the proper mobility on, and that's just going to occur like a small cost. But the thing is, this if you do this all the time, then you're going to just have a wireframe view that is like all purple, right? Now in this case, we made it has become like blue because we just fixed the mobility. But here you can see that this lantern has the same issue. It's actually like pink because the blueprint was never set to have these meshes be static. And I think
really
now
cool to use the wireframe mode to see the mobility of everything.
Yeah, this is what I often use whenever I audit a map, because you can just freeform go through the map and you see all of these things that are like, oh, okay, these are actually never going to move, but they're very brightly glow pink anyway. So that's just a very quick way to just get a little bit of performance in different for a variety of features. Also like shadows, especially if you use maybe non-virtual shadow mapping, like those shadows are going to be cached differently if you just have all of your meshes be dynamic instead of having them be static. And same with collision, they're going to be treated differently. Let me go back to regular mode. So now if we were to just rerun this, we would actually have just one shape that is also then going to be deformed, just like a convex shape. So that's going to be a nice saving. And actually, if you just open up the statistics panel, which again, I've just opened, but it should be, sorry?
We did get an answer from the developer in the chat that said, note that Rails can have hard turns. That's why we added multiple box collisions instead of just one.
Right, that's interesting. So we can have a look at the hard turns, but then maybe the convex collision can still be enough because they, or maybe you have like two of those boxes because the convex shape is still going to be deformed and try to encapsulate the mesh. Anyway, so we can have a look before submitting this randomly to look at the hard turns. But that's it's probably a good reason for having those things. But I think it can still do the convex deformation on like hard turns.
It's still good for the people watching us to know that you can do this, yes.
Yeah, exactly. Like, yeah, this is just all like general fixes. Like a lot of stuff can apply for a lot of games. If you just open up the case visual debugger, you're going to have your own things that are going to show up, your own collisions that are going to be like super strange that you think like, oh, this could actually just be a simple box, or why is this so complex? Yeah, so let's see where. Oh yeah, so one of the things that I was going to open up is actually the statistics panel, which was again under tools. I think under audit, then we have statistics. So I already have it open here. And if we just go and filter based on count, we can actually see that Rails actually has 600 instances. So if we remove like 5 shapes per instance, then we have to remove like 3,000 collision shapes. So that's nice, of course. And I often use like the statistics panel, which is also just like a super old tool, to kind of like get a sense of like what is being used in a world and like what is like very high count. So maybe that's interesting to optimize first, because maybe if we optimize that collision, it's going to be affecting many cases in the world. It's going to be used for many collision queries or physics and stuff like this. The same with size. That can also sometimes just give you an idea of like, okay, what is by far the highest size? So maybe that can be like a very complex like skeletal mesh, or often this would be really busted collision data. If you just have, if the size is really large, which is like the resource size of the memory that it's going to take up, which includes not just the mesh, but also like the collision. So that's really bloated, and this is going to often be bloated, especially if you have a high detailed nanite, because then you don't automatically have like always super optimized fallback meshes. And then those fallback meshes is what's used for, let me show you that as well, for your collision data. So here you can see, for example, we can enable nanite fallback, and then we see like what mesh that gets used for triangle collision. So if you have that enabled, which again is the default, then now we would have like a 3,500 vertices, or like we should have to look at the triangles more, almost 3,000 triangles for the collision. And often you'll have like like hugely complicated nanite meshes, and then the fallback mesh by default can only be so much, have only so much reduction. And so that often needs work. But in this case, the base meshes are not like super highly detailed. So it's actually hasn't been like a huge issue. I think then one actually fun thing with the stats panel, which I also like to do, is just go the opposite way and not look at the most instances, but like maybe look at some, like what has only like one instance. So for example, just earlier I noticed like SM glass A, and I just like click it, and then you just jump to it and you see like, oh, this is interesting because there's only one instance of this thing, and I'm pretty sure you can't see it because it's just little glass thing in the world here. And it just was probably kit bashed from a few houses together. And then someone just didn't notice, of course, that the glass was also moved with it and never removed. So now we can just delete this. And now probably not probably, but maybe this window is never used anymore, this window material. So it's going to be removed from the levels. It doesn't have to get loaded. It doesn't have to get streamed in these textures. It will also not have to send this draw call to Nanite, to the GPU. In this case, actually, it's not Nanite because it's a translucent mesh. But you get the point. If it was an opaque mesh, it would. And also, it doesn't have to do occlusion killing because we know it's always going to be occluded, right? So we don't even need it. And so you can do that with. I often do this with levels as well, just to go through all of them that have one instance. And then another thing you might do is you can't always delete it, but sometimes you can maybe see certain variations and it'd be like, okay, well, I see like this particular cactus. Oh, okay, so this has hardware instances, so we can't do that one. But maybe some other that also have one hardware instance, because hardware instances would be like your instance static meshes and like your foliage, your instance foliage. But then if there's other cases where you might have one mesh of something, maybe you can just swap it out with another variation of another mesh that people are not going to notice. And then, yeah, again, maybe have like fewer materials and fewer unique geometry in your map. So there's often like a lot of like these super low tech tools that are just nice for auditing your environments. Let's see. I mean, I probably have like 6 more hours of things I could talk about, but I don't think we would have the energy to go through all that. But I think maybe you could do a little bit of Niagara, and I mean, I don't know. I just have like a lot more, but we can let's do a little bit of Niagara, and then I think we'll probably be good. We can always do maybe a follow-up, or I'll probably make more of these videos on like my own YouTube channel as well, because it's just a lot of fun to go through levels and make optimizations. And through the power of editing, you can actually, make another build and then run another insights and then call all of that stuff out. But in a live stream, that you can't really do this. So that would be fun to make more stuff for it.
For the people watching this, go to the comments underneath the stream, and if you want more like this, just comment if you want Tom back.
Right. Yeah.
I can already tell you, based off of the live chat, the answer is yes.
Great. Nice. So I guess, I mean, there's a lot to talk about with Niagara as well, but I think one of the things that I think is interesting, also to scale down, is there's a lot of effects in the game that are maybe cosmetic, but again, if someone is running on like a low spec, they're not going to care about the fact that there's some flies around something like a light, but they are going to care about the performance. And so one of the things you can again do, which is what I was trying to show with the detail mode, and then my editor crashed, is that you can just go into the Niagara and then also change the detail mode on that if you just want to have it disabled for that particular like blueprint type. You can make the change here and then say like, okay, apply instance changes to your blueprint, which I think is very useful, because that way you can actually tweak stuff here and also with your lights, and then say like, okay, actually move all of that stuff back into the class rather than having to go into your blueprint and make the changes there and then keep going back to your instance here and just like, okay, this looks good. Let's compile.
I did not know we had this button. Oh my God.
It's very useful.
This is why I love these sorts of things, because you'd be amazed how many things either get added that you just don't know, or just things that have always been there that you didn't know about. And I learn something every single time I watch.
And I wouldn't even be surprised if I already knew this ages ago and then just forgot, and I'm relearning it, and I'm just like, oh my God.
Yeah, exactly. So now you can set it to like medium or high, but probably medium. And then someone that sets its effects quality, I'm not going to try to toggle it again. It was working all day, but I don't know why. If someone sets its effects scalability to medium, or actually if we set this to medium, and now he sets its scalability to low and the effects quality, he will no longer, it's going to simulate those flies at all. And that's just going to be nice because then we don't have to bother with this small detail, which is nice. It adds to the game, but if you really want to squeeze performance, low is the setting for that, right? So that's going to be super useful also for particle effects. And the reason why, I mean, you can also set that in scalability of the Niagara, but sometimes these flies might also get used in a different way that is more interesting. Or I mean, flies is like probably always going to be super ambient, but there's other cases where you might have another use case for a particular effect that's more important or more like gameplay related, and then maybe having this in a detail mode on this blueprint, it's always going to be relevant to just turn it off. And then with the scalability settings in like something like the Niagara system, it might not always be available to like go into the renderer, and then you might be able to like turn it off for low. Now it's also going to just not render if you set it to low on this particular like flies emitter, which I guess in this case is going to be super useful because this is actually a lamp particle system. So yeah, we could just do it here. And then we do want this guy to remain. We do actually want this glowy bit to remain. So this particular case, the Niagara
scalability level in that window. As you're working on it, can you preview what like scalability would look like on low?
Yes. You can actually click the scalability, of course. Yeah, that's very useful to know. So you can click on the scalability, and then you can actually toggle the different scalabilities, and then you can preview what the result would be. So that is indeed super useful to do. So in that particular case, because you do want to keep that this particular sprite, it would be better to not mess with the detail mode and just change the scalability inside the emitter, because we only want to disable this one and keep this one. To be fair, not over here. This is something like this. I would probably make a material, like a billboard material component. Maybe, because that way it's just literally going to be a camera facing plane that we would just apply this material to, and then you're also done. It's never going to do any kind of CPU simulation or pretend that it's a powerful like Niagara particle system. It's just a plane that's going to be super basic. But this also absolutely works, and it's also already a lightweight emitter, which is also kind of a new feature with Niagara, which basically is a stateless emitter in Niagara, which means the feature set is a lot more limited. You can do significantly less, like you have a lot less access to a lot of like querying of data of like the landscape or the depth buffer and stuff like this. But from that loss of flexibility, you also get just more performance emitters, really. So at least it's already a lightweight emitter, so that's pretty nice. Let's see, another thing that I just briefly want to mention, which I think is interesting, and that is something that I think we will be able to like explore more, is choosing like if something should be like a CPU particle or a GPU particle. That's something I would still like to try out more, because the thing is, with this game, we have a lot of CPU time available, relatively speaking, but we don't have a lot of GPU time available. So one of the things that happens often in your in the start of your GPU frame, so now we are back in Insights on the GPU graphics track, you would maybe have a lot of like Niagara stateless and a bunch of other Niagara related render passes in the start of your frame that are all your GPU particles. But we are actually all the time we're GPU bound. And so one of the things that we could maybe consider is just maybe moving some of that stuff back to the CPU, because we have more time available on the CPU. And so maybe we just move it back, right? Because you always have the toggle to like choose if something should be a GPU particle or a CPU particle. And I've seen some cases, I don't quite remember exactly which ones were GPU and CPU, but especially the cases where maybe you only have a few particles, that's better suited for CPU. And if you have particle effects with like a lot of particles, that's generally going to be better for GPU, because the GPU is just a lot more parallel and it can process them in multiples of like, well, I guess depending on the GPU, like 32 or 64 or so particles. So if we have like that, those numbers or multiples of that in particles, it's going to be nice and efficient to run it on a GPU. And so you maybe going to be, it's going to be more ideal for you. But if you have only like one, you got to make that a GPU particle, it's just going to waste a lot of the potential of the GPU, because it has like 64. Now we're getting into maybe too technical aspects of the GPU, but you have a lot of threads available or processing cores on the GPU, and then maybe you're only processing one particle, even though you could maybe have like 63 additional ones for free. So those kind of particles should maybe just be a CPU particle again, especially because we have more space on the CPU than we have on the GPU with this game. Yes. So I think we have a lot more to talk about, but we've already spent a lot of time talking. I think we should probably go to Q&A.
Sure. Yeah. No, and thank you so much for coming on and demoing all that stuff. It's really cool. I know that like, in some instances this stuff feels like, oh, like, does that really matter? It's such a small little thing. But like, as we said before, like each one of these optimizations add up, right? And I think that's really important and really cool. Some of those things, like the collision one, that was a really cool one that I hadn't even considered with the ticking it on and off based off of whether they've, yeah, it was really cool.
Great.
Yeah, we definitely got some questions here, so let's jump in and tackle a few of them. One of the first questions we had here was, since this game is multiplayer, were there some differences due to replication in the graphical optimization pipeline? Something that only ruins, something that only ruins your life in multiplayer only. The other one we had was actually very similar to that. I may have lost it. But we had a couple questions basically. Oh yeah, the trailer showed this as multiplayer. Are there a majority of these optimizations on the client side only? So questions about like, client versus server side.
Well, I think so. Definitely, also they have done some optimization that are also have to consider multiplayer, and also that's maybe one of the ways where not streaming in any of your meshes is going to be easier, because all your collision data is just going to be available, and so the players can be all over the map. So you kind of need all your collision data available at any time, because the host, so the server, is the hosting player. He can be somewhere on the map, but other players also are going to be maybe on the entire other end of the map. And so you need a lot of that data available. And so that's, for example, the collision data is what you need for this. Otherwise, you just start falling through the floor, and on your end, you're not. So then you're starting to glitch all over the place. And so since they're not using world partition, that's actually hasn't been an issue, because we already were not relying on that. They've also actually made a enemy optimizer, which I should call it the optimizer, enemy _optimizer. This is actually one of the components they've implemented, and it's a little bit similar to, if people are familiar with like significance manager, where in that case you actually calculate a value of like, how significant is a particular actor, which could be an enemy in the world relative to me. Which could mean like, okay, it's in my view, it's really nearby. That's like super significant. But if it's like really far away and not even in my view, it's like really not significant at all. So it would have a really low value. And then you would also do this and the server would also have to consider all the other players as well. And then based on where all the players are, you determine, okay, which are the most significant enemies, and then don't throttle those, like don't reduce the tick rates, and maybe keep the mesh animations enabled. Don't have them be nav walking, because if an enemy is really far away and you still want him to walk through the world, you can just enable navigation walking instead of physics walking, which is the default, which actually uses the collision of the environment rather than just having it scroll across the navigation mesh. So those are things you can then turn on and off Same with the tick rate. If someone's really far away, or if an enemy is really far away, and no one is looking at him, you can just start throttling a lot of stuff if you still really want it to simulate, which actually can be really good for gameplay because the players, I also play this game, and so I know that I like run through the map on my mount, and I know that I'm leaving behind a lot of enemies. And if I then turn around and suddenly all those enemies are despawned, or their like movement speed didn't match up because they were no longer like actually simulating, they were being paused entirely or something, you are going to notice the player. So you can't turn off everything, but you can try to throttle as much as possible, which, for example, the tick interval, and just trying to disable updating the skeleton mesh as much as possible. Those kind of things are going to help a little bit. Same with the movement modes of the. They actually, I think they are using character movement component, which strictly speaking is a little bit overkill for enemies like this, which they are also aware of. So we could write a cheaper custom movement component, but they also they haven't gotten around to this. Maybe that's something I could also do for the team as well, because that way you can remove a bunch of the overhead, because the standard character movement component is super capable, but also a bit of a big boy. That could certainly be optimized. But yeah, this is one of the things where you can also already see the server player's distance range. You can already see a function where they do have to keep that in mind. You have to calculate it for all the players. And I think actually I have a project as well. Recently renamed it Project Orion, which is where I also have an implementation example of Significance Manager to like show the general concept of like how do you handle this? Like how do you calculate this for all the enemies? Because especially if, let's say this is not something that they're not doing yet. Like they only do it based on distance. But what if you have like 40 enemies that are looking at you, or you're looking at the enemies and they're all nearby? Currently, this optimizer, as far as I'm aware, doesn't account for that. But something like a significance manager, like Fortnite uses, would actually account for this, because then it puts things in buckets, and it would just say like, okay, on the PC platform, and it can be different on like your Switch or like PlayStation, the first 5 enemies that I consider the most significant, so that might be like straight in your crosshair and really in your face, they are going to have the highest value. And I'm not going to do zero throttling on them, because I know I have the budget on the CPU and GPU for that. And then the next 10 enemies or so, they're going to be in the lower bucket, and they are going to be forcefully throttled in a certain way. Maybe you can set the skeleton mesh min LOD to something like 1 instead of 0. That's actually a common way to force a lower LOD, even though they're close by. And then that's going to reduce the cost. You're going to stay within budget because you've figured out how much you can spend. And you're probably not going to notice as a player because they were less significant. You're probably looking at those other 5 enemies. And then you keep going until like you've filled all your enemies and they've throttled as far as they need to. So that's like a more full implementation of Significance Manager, but this already gets them like really far. Yeah, that's really really long answer to the question.
No, appreciate it. We also had a really important performance question, which is, what is the drawing cursor tool Tom is using?
I always forget the name. Let me see.
I think it's a Zoom It.
Zoom
right?
It. It's Zoom It. Yeah.
Zoom It.
It's super useful because that way I can just highlight a lot of stuff on the screen. It's very nice. I also use it in my courses all the time, because that way I have to do a lot less editing after the fact, because then I can just during the lesson I can show like, this is where you're supposed to look on screen. Like look at this particular pixel here. That's always really nice.
Yeah. Question with the Nanite side. We actually have a couple variants of this one, so I'll kind of summarize it, or maybe just read this one here. Do I understand it the right way? So with Nanite, I can have, for example, 5 different meshes, but if they all share one material instance, the Nanite will draw all those with one draw call? So a couple variants of this kind of question.
Right. So it basically does work like this, because it works like this in the base pass, because what it now can do during the base pass, which is different from what it was before, is it will just assign material IDs to pixels, and that material ID is then just mapped to some material that you have in your game. and then it will just render all of those. It can just render them together rather than having to go on a bird geometry. Like before, it would have to be the same mesh and the same material. And now that's sort of separated.
Because we don't even render the mesh anymore. We render clusters of the mesh. So we can batch all the clusters together.
Another question we had here, and Ari, correct me if I'm wrong on this. I think you said the U object was a 5.8 edition.
Yeah, I just added it in 5.8.
Somebody said here, and I had a response to it. Not sure if it's true, but it could be true. So I wanted to throw it out here. Is how do I see the U object in Engine 5.6? And somebody else said you can run log garbage verbose in the console, and then it will log the U count object count for every garbage collection.
I love that you say someone as if you don't know my username. It was me. I answered that.
Oh,
so,
is that you?
yeah, it's me. It's got my picture there. So, yeah,
I'm looking at a text document here for the question, so I didn't see.
Yeah. So I answered that. Yes. So I always want to know this number. Also, like when we're getting like captures from studios, or even if I get a development build for a presentation, and how I've been getting around not having it in earlier versions of. Earlier than 5.8 is by turning on the log garbage log category. I turn it to verbose. So you can do that by in the console, just write log space log garbage, which is the name of the log category, and then space verbose. So log command, log garbage category, and then verbosity. And you can also start a game with dash log CMDs equals log garbage verbose, end quote. There's a few ways of doing it, but basically whenever a garbage collection happens, then it will tell you how many U objects there were and how many were destroyed, which is a really nice way of doing it. It's not every frame, but it's every garbage collection, which is usually when I care about it, because the U objects affect the garbage collection timing, and that's what I want to know. So it's been good enough for me so far, and then I got so annoyed by it, and I was like looking around the engine, and there's some old U object counter that logs it to CSV, but it's not for Unreal Insight. So it was just a one-line addition, so I just added it.
Yeah, you can also use object or obj space list, and that will also dump all of the objects. And then at the very bottom, it will also give you that object.
That's true also, yeah. Object list.
And that's of course also useful if you want to just figure out, okay, which classes are all of my objects. I often use that for also checking out how much memory is being used for example, collision. Because if you have obj list class equals body setup, I'll put that on that page, the landing page. Then it will also just dump all of the, and the body setup is actually the collision data. It will also just dump that all to the to your log. And if you add dash resource size sort, it will also sort it by size. So then, of course, you get the biggest ones first.
Yeah,
you won't have to remember that. I will just put it in the blog.
Yeah, if you show Tom's screen, you can see the command in action.
Yeah,
right.
So there you wrote it in the editor, and you can see that it gives you a list of like every single class per U object, and it's by default listed by the resource size in total. But for garbage collector, I usually want to know what one has the most count. So you can also add object list dash count sort.
Right. Yeah. That's very nice too. That's a lot of objects. It is a lot of them. So in this case, for example, I did that object list. So it was like, this was the command object list class body setup dash resource size sort. And then you can actually see like, okay, for some reason, some kind of bottle crate healing is actually the largest in terms of collision, which is weird because it's bigger than an entire house. That seems suspicious. So we probably have to open this one up and then see why that's happening.
Lots of cool object list commands, like the ones I use usually is first just object list dash count sort. Then you do object list class, and then you dig deeper into each class. So basically allows you to go and see like the full name of every single U object in your entire game. And then if you want to see them all without having to go per class, you can do obj list dash all, and then print them all out. It's going to be a huge list.
I know we're getting pretty close on time here, but I did have a couple more questions that I wanted to get through. One of them that I thought was interesting is this is, again, kind of a summarization. We had a lot of commentary early on where whether Nanite was necessary for this project. Do you have any practical advice for folks, for how folks should go about making this decision on their own projects, or maybe how they could test performance between the two?
Well, that's the thing. So when I first got onto this project, I was surprised that it was Nanite, because I just hadn't expected it, because I thought, okay, it's going to be a stylized game. It's probably not going to be Nanite. That's going to be interesting for me because I can, do some old optimization tricks that I know from UE4. I thought it was going to be fun, and then it was Nanite. It's like, oh, actually, I can't use all my old tricks anymore. So I was a bit surprised, and I guess, yeah, you can obviously make this game without Nanite, but then it probably wouldn't use virtual channel mapping or Looman, but you can, we made beautiful games before Nanite, so certainly you don't necessarily need it, especially for like stylized game, because they don't have like super detailed geometry. But like virtual channel mapping is like, that's probably one of my favorite features of UE5, actually more so than everything else, because you can just have like mega long shadow ranges now, which was a bit of a pain with cascaded shadow maps, and you would of course have to combine that with something like distance field shadows for further away distances. That was a lot of tweaking. So I would say they're making it work quite well. I think the game runs really well. You can also see on Steam people are happy with the performance, and we're still going to make it run even better. But strictly speaking, it doesn't need it. But to also do the comparison of the A and B is super difficult, because you can't just turn off Nanite and be like, oh, actually, this without Nanite, it runs really well too. Because then you have to start making all of these manual LODs and maybe set up more distance culling on all of the individual meshes, which is actually not something that's supported anymore with Nanite. But with non-Nanite, you would have like these distance culling volumes, which if a mesh is below a certain screen size, it would just get culled, and it would not even have to bother with occlusion queries and stuff like this anymore. So there's a lot of manual work to really optimize your scene with non-Nanite, and then you can compare it with Nanite. So I guess it's not like a simple A/B test. It would really take some effort to do the comparison.
Yeah, and as you mentioned before, I mean, I think a lot of folks are looking at this, they're looking at the geometry density and saying, oh, the geometry density isn't that high, so therefore don't use Nanite. Like, why use Nanite? But as you said too, like with virtual shadow maps and other things like that, and even like a big one for me that I think is an important thing is like, it basically gets rid of LOD pop-in. It gets rid of the work of having to do LOD and things like that. So there's more to Nanite than just, I can put, millions of polygons into my scene and it still run. That is obviously probably the biggest consideration, but there is more to it than just that.
Yeah, it's a huge time saver when it comes to development.
Yeah, a lot more stuff is easier to optimize for, which was a bit of the pain in the history of like optimizing it manually. But yeah, you can with a game like this, which is super stylized. You probably could have gone away with not using Nanite, and then maybe using like traditional cascaded shadow maps, distance field shadows, and maybe a little bit of like finding some alternative for Looman. I mean, they have just deprecated screen space global illumination, which would have maybe helped a little bit. But also, I think Looman is just a nice little polish on top of everything. But that's also another thing, that if people like really want to squeeze the last few frames per second out of it, they already optimized Looman quite a bit, by the way. So it's not a huge performance loss if you enable Looman. And you can see that the game runs really well with all these features enabled. So it can be optimized for like a stylized game or a realistic game.
Yeah. Another question we had here is there such thing as too much optimization? How do you determine whether the juice is worth the squeeze? Only after you dip below a threshold?
Depends on when you need to ship.
Yeah.
When you run out of runway.
Yeah, there's a lot of ways to consider this. I think you have certain budgets in terms of like what you want to achieve and on what kind of like hardware you want it to run on and how far you want to scale down. And so you can consider maybe that could be your target. But Yeah, it really depends on what realistically you can achieve within the time that you're also given, because it's not always the case that you can just endlessly work on a project, even if you might want to have this run on every single piece of hardware ever. But maybe once you achieve certain optimization targets, you think like, I guess we can squeeze more out of it. At least that's what my way of thinking. I always want to go to the next tier down in GPU and just keep going. So long as someone still has that GPU in their PC, it would be fun if it can run on it. But the more realistic answer is that at some point you just run out of time.
Yeah, and also you get diminishing returns. Like you see these things kind
Definitely.
of like, oh, huge time saver, I do this, like low-hanging fruits. And then eventually you're just spending so much time on like cutting down these 0.0 something milliseconds. It's just not even worth it anymore.
Absolutely, yeah.
Yeah, and performance is a relative thing, right? Too. I think that was an important thing that you said as well. Is like, for you in that instance, it was 1 millisecond down to half a millisecond, but that might be 2 milliseconds down to 1 for somebody else, right? And that might seem like a larger difference in comparison, but it's all relative, right? So I think knowing like a rough idea of like how much of a performance increase you're going to get from that, and then having a target goal, and then like you said, if you have runway at the end, maybe once you get below that, then you start looking at the things that are on that higher end of that lower portion of it, and then maybe optimizing from there. I think how much time do you have, Tom? We got time for a couple more questions?
I got more time, yeah.
Great, perfect. This one might be a little in depth too, but what kind of blueprint code or portion of code is worth shifting to C++ to improve performance?
Right.
The kind that shows up on the profiler.
Yes. Actually, if I can remember the name, I can maybe show something. If it's in this one, we'll see. Autophysic. So if you can maybe show my screen.
Yep.
Let's have a quick look. I'm just going to see if I can find it. So one of the things I often like to do whenever I'm in Insights is to, well, in this case, I already know like what I'm looking at, but I can show some examples of where I don't know what I'm looking at yet. But for example, this autophysic is like a function that they're calling on a timer to turn off and on certain things as an optimization. But that's a classic example also of maybe something that we want to plot on a timer and maybe do in C++. So if you right click on that autophysic, plot timer, and then add game frame stat series to graph track, then it's going to show this, and you're like, okay, this is showing me nothing. So then you hold down shift and you do the scroll wheel to actually re-graph it to make any sort of sense. And now you see kind of like the super common issue with when you're trying to optimize things using timers. And that is that you're sort of like letting fate decide. You're saying, roughly 0.1 seconds, you just run your timer based on whenever you respond in a world that you're not really super sure about, also relative to other objects. And so you're like, maybe that's going to be good. But the problem is you don't really do any sort of frame pacing with this. You sort of just like loosely pace it out across like a second, but not per in between frames. And so we can see here that we get these spikes where probably a lot of them were just calling their begin play in that particular frame when we first loaded in the map. And so they all are on that same cadence or something like this. And so what you see is that some frames have maybe only a few in our timer manager. And in other cases, you have a whole lot of them. So there we can see. So this is a whole bunch. And so the intention here is good in that we're trying to like probably see autophysic and you see blueprint time. And then underneath you see a bunch more like, okay, we see doing a get camera manager is valid, get camera manager. We're doing a bunch of stuff. And in the end, we do set generate overlap events. So yeah, it's going to toggle something to try and optimize itself, which is definitely a good thing. But there's a couple of issues with this. First of all, we no longer really control like the frame pacing. But also, whenever you do a lot of these small functions in timers, you also have a lot of like overhead from stuff in between. And this is going to add up to, 0.2 milliseconds of just toggling And it can also be like, if you try to run this on a Steam Deck, it's going to be a lot worse. And I've also had other levels where this was 0.4 milliseconds or so, just to toggle stuff. And that's a classic case where if we just do a little bit C++, because it's going to be super easy to do in C++, even if you don't know a lot of it. Because you could, for example, just make a tickable world subsystem. And whenever this owner, whoever owns this, let me just go quickly show you the name of the whatever object this belongs to, which is a BP physic object. Whenever this guy calls begin play, he will just add itself to an array on that world subsystem. And that subsystem can now, it could even do it every frame. You don't even have to throttle it anymore because it's going to be so fast in C++. It can just iterate through the entire array of all of the physic objects in that world and just do a distance check to the one player or all the players and just toggle itself on or off as it needs to and no longer run it in this timer. Now, this is going to be like a fraction of the cost. And we know like it's going to be the same cost every frame. And you don't even have to do any smart filtering on what to run every frame. You could still have a bit of a loop, go through the loop, like every frame you run the next 10 or 20 or so items. But I think it's going to be so fast that you can just blast through the entire array, and it's not going to even show up anymore on your insights. So that's the classic example where a lot of this stuff is going to happen, or where a lot of people are just going to offload their optimizations to like just run it on a timer. It will be fine, and then the timer ends up being 0.5 millisecond of stuff that could have been basically like nearly instant if you did it in C++.
Also, I want to point out that the space between those blueprint functions, that is literally like the overhead of blueprint. So if you're calling a lot of functions in blueprint, it will usually be like the overhead starts showing up there, and then maybe that's code that you can do in C++. But usually, like once you call a blueprint function, that is kind of like an exposed C++ function. Like after you've called it, it's just in C++, then you come back up. So I actually have a whole section of that in one of my presentations called Myth-Busting Best Practices in Unreal Engine. So I spent like 10 minutes talking more about the blueprint overhead and when you should convert to C++ and when not.
Yeah, and also this is probably also going to be time spent running more code in the timer as well, the timer manager itself, before it can finally invoke the next blueprint function. So some of that's going to be C++ and some of it's maybe loading in the next memory, the next chunk of data for whatever blueprint it wants to run. Yeah, for sure. So that's definitely an example that I just remembered that I noticed recently that could easily be converted.
Awesome. Final question I'll throw at you. We got quite a few good ones, but I think this one's a really cool one, or maybe even an important one for some folks here. Is when doing a graphics menu and scalability system for their own project, how do you deal with decoupling VRAM hungry settings like volumetric resolution and shadow map resolution?
Can you say that one more time, that question?
Yeah. So when doing a graphics menu and scalability system for their own project, how do you deal with decoupling VRAM hungry settings like volumetric resolution and shadow map resolutions that are probably set under a single, parameter or scale?
Right. Well, the thing is, so often they will kind of have to be tuned together with like other settings that are related to like shadows. Like a volumetric, actually the funny thing is that volumetric quality is indeed under shadows, which I've always found like, I can kind of understand it, but I found it a little bit strange. I would maybe put it more under effects because it feels more like fog. It is actually, in fact, like stuff that can have lighting and shadows in the volumetric fog. So in that sense, maybe it is shadow related. But you can actually add a minus in front of your scalability setting. And so in your default scalability .ini, you can add a minus to like some control variable in like the shadow quality group, and then you can just add it to another group. Right. So at that point in your default scalability, you've just removed it from the shadows group if that's not where you want it to be, because it has been defined as such in the base scalability ini. And then you can just have like, okay, I'm going to add it to the effects quality group. So that
you have
might
a lot
be
of control over scalability groups. You can override almost like, if not every CR in the engine.
Yeah. So this way you can just literally relocate it to another group if you wanted to, just by adding the minus.
Very
And then
good.
make sure you do that to every tier, right? So just make sure you put it in all of the tiers. Otherwise, when you switch tiers, it's only going to grab some values from the base scalability and some from the default. So
Anything else that we wanted to cover while we had you folks here today? I mean, it sounds like there's plenty more, but in the time that we have allotted for the day, is there anything else we wanted to touch on while we were here?
Well, performance optimization is like a ever increasing in demand thing for games nowadays. And I say like anything, I'm so glad everyone came here to watch this, who's watching the stream. And if you want more of this, we do have an optimization learning path on the Epic developer community. You know what? I should have linked it, but maybe
I might be able to find it.
I have the link. Give me 3 seconds. I got it. Copy link. I will give it to you down here in the chat. Please forward it. We have the Unreal Engine Performance Optimization Learning Path, and this is a path made by us in the technical developer relations team at Epic Games, and we'll definitely be putting this under there. But like, it's got so many optimization stuff, you can see them all there. And I also want to give out special thanks, huge thanks to Evil Raptor for letting us show their game Far Far West, and because it's a very vulnerable thing to show your game and have like people like me and Tom poking it in front of a huge audience.
Right.
So just like, thank you so much for Far Far West.
Me intentionally not fixing issues so that I could show them on stream, and then after this stream I will fix them. But as I found them, I was like, okay, we can show this on stream. That would be fun.
Yeah, no, definitely.
They will
shout
be
out
fixed.
to the team for
they will be fixed. Yeah,
for doing this. This is great.
I wonder. Put this one at the end.
Yes.
This game is Hits Hunter approved.
Wait, hold on. I need you to do it one more time. There you go.
Hits Hunter approved.
Perfect. Tom, anything else from you?
Well, actually, I have that optimization landing page that I think would be interesting, because I'm also going to add this stream to it, and I have a bunch of other long form tutorials on there as well, like another 1 hour of profiling the Dark Ruin sample by Epic, and another hour of optimizing GPU performance from Far Far West. I also have actually that GitHub project, the open source GitHub project as well, that has a bunch of optimization code examples that you can go through, which has some like object pooling that we also mentioned, like data-oriented programming for things like super optimized projectiles, rather than having to spawn a bunch of actors. You can just represent them with pure bits of data, which is going to be super useful, and other ways for frame pacing. Like, there's a whole bunch of stuff there, and I have been working on that project for a couple of years for like the C++ course, but I'm also extending it for like optimization and things like that. And of course, I have more blogs as well. And on this page, I'll also make sure that I add all the CVARs that I mentioned, because there was quite a lot, and it's going to be a nightmare to go through the video to remember what I all said. So I will check them out soon.
Yeah, and I just put that link in the chat now, and then we'll also make sure that these links are posted in a pinned comment on the YouTube VOD for those who weren't able to watch live. So look out for that too.
Excellent.
Perfect. Well, thank you both so much for coming on and doing this. As Ari also said, huge shout out to Evil Raptor for letting us come and deconstruct their game live and explore all of that in front of our audience here. I think there's a lot of really invaluable snippets and lessons that come from a real world project, rather than something where you're just kind of pre-building it as a use case. A lot of these things slip through the cracks. Simple things like writing 4098 instead of 4096, like little things like that you might not think of, that are really important, and I'm appreciative of them for letting us come through and dig through all this stuff. So
absolutely.
Folks, that is going to wrap up today's Inside Unreal. Again, a huge thank you to a wonderful guest, and a huge thank you to Evil Raptor for letting us dig through their game, and a huge thank you to you all for watching as well. The show would not be what it is without you, your questions, and your time. And if you came through partway through the stream and would like to rewatch a section, No worries. We post all of our live streams in VOD format on both our Twitch and YouTube channel. You can also keep up with all the latest news, shoutouts, and other cool information on our socials at Unreal Engine. And if you haven't already, please come join us at the Epic Developer Community, where we have our documentation, tutorials from both Epic staff and the community alike, our forums, and much, much more. But again, huge thank you to you folks. Huge thank you to you. And tune in tomorrow, because we have a bonus Inside Unreal this week with the Game Animation Sample Project team that are going to come and show us some cool stuff that they've done in 5.8. So you're not done with us yet. We still have another full live stream tomorrow as well. So please come and check that out, because I got a sneak peek of it today and it's pretty cool. So you'll want to check it out. Tom, Ari, thank you so much for joining us, and we'll see you all tomorrow.
Right. See you. Bye-bye.
Bye, everybody.
Bye-bye.